Welcome back. Not all functions have inverses. You remember, only functions that are one-to-one have inverses. If they aren't one-to-one, we're going to have to make adjustments. And we did that before. Usually we restricted the domain. So functions that are one-to-one means that each x maps to exactly one y, and each y goes back to exactly one x. No extras. The graph had to pass the vertical line test, which told us that each x goes to exactly one y, and also pass the horizontal line test, which tells us that each y maps back to exactly one x. If a graph cannot pass both the horizontal and vertical line test, sometimes we can make adjustments by restricting the domain. Doesn't always work, but it did in the case of the parabola. If we took the basic old y equals x squared function, that does not pass the horizontal line test. The inverse does not exist. So what we did, we said, we're only going to look at part of it. We're just going to look at the right half. So we restrict the domain of the original function to the non-negative parts. And then, because what we had now was just this portion, it did pass the horizontal line test as well as the vertical line test, and the calculator was able to calculate square roots for us. Clearly, the sine, cosine, and tangent graphs do not pass the horizontal line test. Their inverses do not exist. Every single sine value is going to go back to multiple different angles. Likewise, every cosine value is going to go back to an infinite number of angles. And for the tangent values, same thing. Many, many angles are going to have these same many, many y values are going to have these same angles. So how do we fix this? It wasn't a problem with right triangles, but on the circle, every single angle has an infinite number of coterminal angles that are exactly in the same position. We're going to try to get around it the same way we did with the parabola. Find a section of the graph and restrict the domain. Use only part of this winding infinite graph here. So we need to have a part that will include all of the sine values so that we can work backwards to get the angle. But we don't want to repeat any of these sine values. So going from 0 to 180 isn't going to help, because we would have the same sine value here as we did here. We could go from 90 to 270, that would get them all in. 270 to 450, that'd be more than once around the circle. Well, our ancestors chose to go from negative 90 to positive 90. This section right here. They're going to restrict the domain on the sine function to only negative 90 to positive 90. Now those are degrees. Could also be from negative pi over 2 to positive pi over 2 if we're working with radians. And we will include every possible sine value from 1 to negative 1, but the calculator will only give us an answer that's from negative 90 to positive 90, which means on our circle, the calculator is only going to return answers that are on the right half. From negative 90 or negative, we could say negative pi over 2 up to positive 90 degrees, positive pi over 2. In like fashion, we're going to have to find a section of the cosine graph that will give us all the values from positive 1 down to negative 1 without repeating any. Well, negative 90 to positive 90 is not going to work because we would be repeating cosine values here. This one's not a hard choice. This is going to go from 0 to 180. So we will restrict the domain of the cosine function to 0 degrees to 180, or we could say 0 radians to pi radians. We will get all the cosine values from 1 down to negative 1, but the calculator will give us back only angles from 0 to 180. So no matter what cosine value we put in, the calculator will only give us answers from 0 to 180. It will give us answers in only the top half of the circle. Sine will give us answers in only the right side of the circle. Got one more here, the tangent, with all its beautiful asymptotes. Again, it does not pass the horizontal line test. So we're going to restrict its domain. Going to pick one of these little twisty things that sort of look like cubic graphs. And one of those will do. Our ancestors chose to go from negative pi over 2 to positive pi over 2, which also known as negative 90 degrees to positive 90 degrees. And that's going to be the domain. If we want to do inverse tangent, we'll have to restrict our domain. That way, we'll be able to work backwards and get only one single answer. So this ends up being the same as, whoops, got going. Sorry about the mess. It's supposed to be negative pi over 2 to positive pi over 2. Either way, it's the same as it was for the inverse sine. The original function had to be restricted. Same values, which means no matter what tangent value we put in the circle, we are only going to get an answer from negative pi over 2 to positive pi over 2, or from negative 90 degrees to positive 90 degrees. If you notice, we have the right half of the circle, we have the top half of the circle, we have the right half of the circle. The calculator will never give us an answer that's in the third quadrant. Now there are angles out there in the third quadrant. WER. We're going to have to figure them out for ourselves. And that's what we're going to do next. By restricting the domains of each of the trig functions to either negative 90 degrees, positive 90 degrees, or in the case of the cosine, 0 degrees to 180 degrees, we were able to eliminate the infinite coterminal angles. However, with a possible exception of quadrantal angles, every sine value will have two angles in the circle. Every cosine value will have two angles in the circle. So will every tangent value. The calculator will give us one answer. It won't give us any answers in the third quadrant. So from the one answer that the calculator gives us, we will have to find the other angle that has that same trig value. For example, suppose sine of theta equals a half. So we could ask the calculator for inverse sine of a half. And I'm hoping you're using the best calculator. Inverse sine of a half tells us that theta is 30 degrees, which is absolutely correct. 30-degree angle has a sine value of a half. But there is another spot on this circle where the y value is exactly the same. There's another spot over here with the same height above the origin. So there's another angle over here. We have a 150-degree angle, and its sine value is also 1/2. So the first angle out of the calculator was 30 degrees. We also have a second angle of 150 degrees. And if you take the sine of 30, you get 1/2. If you take the sine of 150 degrees, you get 1/2. We could try a second example. Sorry about the circles here, not being quite round. If we take, knowing that the cosine of an angle is 1/2. So inverse cosine of a half is going to tell us the angle. I'm hoping you remember because we did this just a moment ago. Our first angle, the one you would get out of the calculator, including your brain, is 60 degrees. And that is correct. 60-degree angle here has a cosine value of a half. Now cosine, those are the x's. There is another spot on the circle where the cosine value is also a half. If we come all the way around to here, which would be a 300-degree angle. So our second angle on the circle with a cosine value of a half is 300 degrees. It has the same x value going across as a 60-degree angle did, right across here. If we let the tangent of the angle equal 1, then we could do inverse tangent on 1 to find our angle. The calculator is going to tell us 45 degrees. And that's right. 45 degrees here does have a tangent value of 1. The sine and cosine are the same. There is, however, another place on the circle that has the same tangent value. Right over here. Because tangent is sine divided by cosine. We're going to have the same sine height, except it's in a negative, and we're going to have the same cosine, except it's also in the negative. So this angle right here, which would be 225 degrees, has the same tangent value. If we tried the tangent of 225 degrees in the calculator, it would tell us that the tangent value is 1. But if we tell it that the tangent value is 1, it will not tell us that 225 degrees is a possibility, because the inverse tangent function only works on the right side of the circle. So we are going to have to draw circles, come up with something that will help us get the second angle. And we can do that. We have some actually pretty simple rules to get the second angle in the circle. First of all, we'll have to get the first angle in the circle. And there's a different rule for each one of these. For inverse sine, the second angle is going to equal 180 degrees minus whatever the calculator said. The calculator says that the first angle is 30 degrees, we'll subtract 30 degrees. If the calculator said that the first angle is negative 50 degrees, we will subtract negative 50 degrees. Whatever the calculator answer is, that's what we subtract. Could also be written as pi minus the calculator answer, if we're in radians. For inverse cosine, of the angle, the second angle in the circle is going to equal 360 minus whatever the calculator tells us. Or we could do 2 pi minus the calculator answer. And finally, for inverse tangent, we're going to get the second angle by taking 180 degrees plus whatever the calculator answer is, or pi plus the calculator answer. More stuff to remember. So we can see if these worked. For our first one, we were doing inverse sine. The first answer right off the bat is 30 degrees, has a sine value of 1/2. We can get the second angle by taking 180 minus the first answer to give us the 150. Cosine, inverse cosine of 1/2, we said was 60. To get the second angle, it says take 360 minus whatever the first answer was. That would give us the 300. And on the inverse tangent, our first response that was that 45 degrees has a tangent value of 1. If we take 180 plus that answer, we do get the second angle in the circle with a tangent value of 1. There is one more thing. If we're finding angles within the circle, degrees has got to be from 0 to 360, radians has got to be from 0 to 2 pi, then none of our final answers can be negative. Our first and second representations of the angles might be, but none of our final answers can be negative. And if they are, we're going to have to fix it. So what we do then is we would take this negative angle and either add 360 or take the negative angle and add 2 pi. Get the coterminal value for this negative angle. So, some steps. 1, get the first angle from the calculator. Even if the calculator is the best one of all, your own brain. Then find the second angle by doing one of those subtraction or addition problems. Inverse sine, we took 180 minus the first angle. Inverse cosine, we took 360 minus the first angle. Inverse tangent, we took 180 plus the first angle. Now if it's in radians, this would be pi minus the angle. And for inverse cosine, it would be 2 pi minus the first angle. And for inverse tangent, that would be pi plus the first angle. Then we go back and check our final answers. If these come out negative, that's okay. We leave them the way they are. But if if either one of these two angles is negative, we find the positive coterminal angle. By adding 360 if we're in degrees, or adding 2 pi if we're in radians. Oh, I know that you must be anxious to try some of these, so if you would please print out lesson 6.8 basic inverse trig, and it says EX 2.10. Make sure you have a calculator and come back soon, please.